Hello, everyone. Welcome to the video interview of ISAC Focus. I'm Nuria Gonzalez Prelcic, a professor at the ISAC department in North Carolina State University. This video interview is part of the multimedia newsletter promoted by the Integrated Sensing and Communication Emerging Technology Initiative. And I am really excited about being here with you, being part of the ISAC research community, and sharing with you all these discussions about latest results and challenges in this research area. The first issue of the electronic newsletter and the interview will focus on the application of ISAC technologies to vehicular networks. We have here with us today to discuss this topic our first invited researcher, Dr. Christos Masour, professor in the Department of Electrical and Electronic Engineering, University College London. He has a track record of publications in joint radar and communications with many contributions to the area of vehicular networks. He is also a member of the CONSOC ISAC Emerging Technology Initiative, so I thought he could be the perfect researcher for this first interview. Christos, nice having you here today. Thank you for accepting my invitation again. Before proceeding with more technical questions and given your role in the ISAC CONSOC initiative, I would like you to give us a summary of the activities that you're planning for the next months besides this multimedia newsletter.
First of all, thanks, Nuria, for inviting me to this. So this Emerging Technology Initiative on ISAC, so Integrated Sensing and Communications. So we've started this effort. I'm a vice chair, and it's chaired by Dr. Fan Liu. And we started this to kind of try to organize the researchers a little bit in the area under the umbrella of IEEE. In the area of joint radar and communications. So building together some of the best reading, some of the latest research that's been happening, but also organizing training events, webinars, tutorials, also organizing special issues, special sessions. So trying to bring, the community, its emerging research area. And we've observed that it's there's a lot going on recently. And it's going to grow, is our prediction. So we wanted to bring together, all these research efforts and to organize ourselves a little bit and have, let's say, a community that we can establish. Maybe in the future, we might introduce some dedicated symposia on ISAC, so integrated sensing and communications in flagship conferences, another aim is to try to engage with the radar community that have similar initiatives, with the Signal Processing Society that have similar initiatives. So to build a wide, worldwide vast network on this.
So maybe we can move now to a more technical perspective. I would like to start talking about deep learning. This technology is now being extensively applied to many problems in wireless networks, from CSI acquisition to network parameter optimization. Even though there are some works that apply deep learning to the design of joint radar and comm systems, it seems there is a lot of space for new contributions. And I wonder, what's your perspective on the role that data-driven approaches could play in joint radar and comm? What are the challenges that still remain and can be better solved with deep learning?
That's a very good topic and a very wide area. Already in the communications-only literature, it's a very wide area. People are applying deep learning to detection problems, channel estimation problems, transmission problems, resource allocation problems. And now once you have a system that does two things, communications and sensing, it's another wide range of problems that you have, and many topics where you can apply deep learning approaches. So on the detection side, for example, you're no longer detecting data, where there's already a lot of deep learning, literature going on, but you also have, target echoes and tracking targets and recognizing, classifying targets. So there's many open new problems that you can apply deep learning techniques. Often these are, not easily to track mathematically. So that's another, motivation to apply deep learning. On the transmitter side, my own group has done some work on joint waveform design, so a waveform that's good for both communicating information and detecting targets. Again, once you start using, let's say, complicated bottom line radar metrics, like the Kramer-Rao bound or other communication metrics, again, things can become quite complicated, and that's another area we can apply deep learning, and we started looking at this. Now, if we want to talk about vehicular communications, which I guess is more of the focus of our discussion, one nice application I see for, first of all, for this joint radar communications is you can use the sensing functionality to actually assist the communications functionality.
Yes.
And this is by removing the need for CSI and the overheads for CSI. So where instead, where before you had the communication only link, where you had to have feedback from the vehicle to the roadside unit, let's say, for establishing the link, for detecting the CSI, or for BIM index, selection. The sensing capability actually circumvents a lot of that, because once you sense the angle of arrival, let's say, from the vehicle, you have a good estimate of where you want to point your beam. So already the sensing capability, saves a lot of overheads in there. And this has been shown already. Our own work has shown some of that. Other people are also working on this. It's been shown that you can exploit this sensing functionality in relatively simple scenarios, maybe one vehicle in a linear trajectory. And things there are relatively, straightforward. The math is not that complicated. But once you have, let's say, non-linear trajectories or many vehicles, things again become quickly quite complicated. The math, it becomes too difficult to track. And then that's another problem specific to vehicle communications where you can apply deep learning. And there's another issue that rises in these situations. Once you don't have this feedback, and you don't have, the exchange of IDs between the vehicle and the roadside unit, another challenge is to associate each beam with a different vehicle. So beam association or data association. So which beam is pointing to which vehicle, and what data I'm going to transmit to which vehicle. And that's another, classical machine learning, problem that it's interesting to look at. So many open problems. It's a wide open area. If you think a lot of problems in the communications only area, there's as much or maybe more problems in the joint radar communications area, where you can apply these deep learning approaches.
Yeah, I agree. You can get really interesting results. In my group, we are also working on that idea of radar-assisted communication, and we have applied deep learning too. And what I like is that it works very well also in non-line of sight situations, can work very well there too.
Absolutely.
And multi-user environments. So where environments which are complicated from a propagation perspective and difficult to model mathematically, you really find interesting results. So
exactly. Yeah.
And this is just starting. So I think
many open problems. Looking forward to seeing your work in this.
Okay, let's move now to another issue that I think it is especially relevant in vehicular networks. I'm talking about security. Yesterday, I read your paper, very recent, available in archive, on how to design the joint radar and communication waveform, introducing security considerations. I wonder if you could give us a summary of the state of the art on this topic and what are the challenges that need to be addressed.
Yeah, I think this is a particular challenge for joint radar communications, and it has some uniqueness, in this topic, because once you have, let's say, a signal that is good for, it's the radar probing signal that is good for detecting a target that also carries information, it means that now the radar signal is prone to eavesdropping from potential targets. And if that target is, let's say, malicious or non-cooperative, you want to make sure that the data you want to communicate with the communication users is not being eavesdropped from the radar target. And that has some nice trade-offs, where on one hand side, you want to beam power towards the target, to detect, the target parameters. So you have to beam power towards that target. But at the same time, towards the same direction, you want to limit the useful signal power that's being received, to limit the capability of the target for eavesdropping, if that makes sense. while at the same time, you want to, of course, guarantee the quality of service of the communication users. So this secrecy constraint and the radar SNR constraint that happen at the same direction, there are two conflicting kind of objectives, and they are quite interesting to see analytically and how to tackle these in practice. So I see this as one of the major challenges that needs to be addressed before we can apply this dual functional transmission. Because if this joint radar communication is not secure, it won't be adopted very quickly.
Yeah, I totally agree. And there are so few papers on this topic that is completely open. I think it's a good
There's
opportunity.
a few opportunities as well there as well. So the sensing capability on its own is kind of an enabler for physical layer security. So if you've been following this physical layer security literature, a lot of the works there assume some sort of knowledge of the eavesdropper, right? Which is not very practical, I guess, in many scenarios. But this sensing capability can give you some information from angles of potential eavesdroppers and so on, and that will then can inform you or how to do secure beamforming towards which directions. So the sensing capability is also an opportunity here to assist secure communications. So again, many nice open problems in this area.
Okay, I wish we had more time for a longer discussion, but it's time to end the interview. Thank you again for sharing your thought and your perspective about this exciting area of research. I really hope many more researchers find our ISAC newsletter and this interview interesting and can contribute to this area with new amazing works. And see you all in our next interview, where we will focus on ISAC for cellular networks, and I will interview Professor Mika Valkama at Tampere University. See you then.